We're going to take a look at a fine-tuned model, which can evaluate summaries without a complex system prompt. There we go. Normally, this requires a very complex prompt, as you see, with a bunch of criterias and steps for each criteria. By fine-tuning, we are eliminating all this. In this video, we're going to look at a complex system message for document summary evaluation, which is this right here, which I found at OpenAI's cookbook. Now we're going to download Wikipedia articles and split them into small pieces. We're going to get them summarized by GPT-3.5 instruct, so we're going to actually learn more about that. Then we're going to get those summaries evaluated by GPT-4 using the complex system message, save them to file, create a fine-tuning dataset to fine-tune GPT-3.5 Turbo, and then we are going to evaluate the summaries without the complex system message, such as like this. So get ready, we're going to learn a lot of interesting and valuable knowledge about GPT's API, fine-tuning, and more. I will take you step by step through 8 files, which will end up by fine-tuning a GPT 3.5 Turbo model. So we have this file from OpenAI's cookbook, which takes in some text and has 2 alternative summaries for that text, which then uses a very complex evaluation prompt template using different relevancy metrics, such as fluency, consistency, so on and so forth. And then assigns numerical values to each. If we run this, we're going to see that the first summary actually gets higher marks. Fluency is scored out of 3. The second summary is actually the worst of its worst summary. This actually works really well, but the prompt is really long, as you can see, and it's quite complex to build it with criteria, steps. I wanted to create a project which uses the evaluated summaries to be able to fine-tune a model. We're going to create a data set from that. This is the fine-tuning data set, and then we're going to fine-tune GPT 3.5 to do the same thing that this complex code does. We were to take a look at this code. Like I said, we get some text. We have a reference summary, which is a human summary. This is just for reference only. We have the first summary and the second summary, the first summary being the better one. And then we have this evaluation prompt template, which has a lot of information in it. It takes in evaluation criteria. It takes in steps for that evaluation criteria. It takes a source text and a summary, and then asks for that metrics score. As you see, relevancy score criteria is defined, and its steps are defined right here. Same goes for coherence, consistency, fluency. We create this function to actually make this call, and then by creating a dictionary from all the metrics, we actually loop over those metrics and get a score for each using the get eval score function. And then we just simply print them here, in this case, like a table. But essentially what this does is just rates a summary in comparison to the original document based on coherence, consistency, fluency, and relevance. If you can imagine, if this was a production app, then for each call, we would have to send this entire prompt template with all this additional stuff. So what we're going to do is we're going to use this to create a fine-tuning data set, and then actually fine-tune so that we only use a very minimal system message. And as you can see, even though we haven't defined anything about what these relevance, coherence, and how they're rated, it automatically knows that they are rated from 1 to 5, and fluency from 1 to 3. In the second step, we are going to download Wikipedia articles and save those articles. We're going to save each and every one of them to a JSON file in its full. But then we're going to split them into 2,000 character chunks and then save them to article chunks.csv so that we can actually summarize. This ends up having about 900 chunks we can summarize. Before I continue, I just want to mention I will have all these code files in Patreon, along with 130 plus other projects, which you can take a look at if you're interested. I always review the code in my videos, but if you want the convenience of downloading the code and playing with them, this is a great way to do it. This project actually cost me $60 to test, and I didn't create that large of a data set, but GPT-4 gets pretty expensive with this kind of stuff. But anyway, let's continue. So in step 2, we download Wikipedia articles based on this Wikipedia articles list, which I had created, and then save them each to article.json and article chunks.csv. And in the third file, which is the get summaries gpt.py, we open that file, we read each chunk, just like this, and then we define a GPT summarizer, which is going to take in a chunk, and it's going to use actually 3.5 Turbo instruct. As you see, we are using the completion endpoint. This is the newest model that was released as of this time. And our prompt is summarize the given document under 30 words while keeping all essential information. And then we get the summary from the response, just like this. And we return it. We return a dictionary. And then for iChunk, enumerate and article chunks. Here, in this case, we're just using the 10 of them. You can just get rid of this to be that, so that you can be dealing with all of the documents. I just was going a little bit at a time just to test it out at first. Okay, and then we print working on chunk, whichever chunk, and then we get a summary, prepare that, right? And then we append that. And we get the summary, and then we create the chunk and summary rows. And then we appended the GPT summaries. And then we write it with CSV using the CSV library to the summaries, GPT chunk summaries.csv. And it looks something like this. It looks a bit jumbled up, but actually this is a CSV file and it actually works well. The CSV library is very good at handling escaping of characters and whatnot. I just changed the file name to a test file. When we run this, you'll be able to see what's going on. So you're working on chunk and getting all the chunks ready. And this is a sequential operation. And we have written it right here. I have the same file in step 4, but this time we are doing it in parallel using thread pool executor. We define the process chunks. We define a file name because I'm going to explain why we're doing it here. Then we try to open that file name. Otherwise, if it doesn't exist, we create it. And then we say how many chunks to process. I came up with this method so that I can actually go a little bit at a time if necessary for testing purposes. Then we open the article chunks.csv, which contains all of our chunks. Then we get all the chunks based on how many we want to process, just like right here. That's why we check if how many chunks to process. If this were to be like an empty string, then it will actually skip this part. So article chunks will be all the chunks. If you were to put in, say, 30, then you'll be only getting the index up to 30th index. And we have tenacity. We are using tenacity for retry. So we're going to use 3.5 turbo instruct, which is quite a lot of rates, quite a large rate limit per minute. But this can still be necessary. I was running into rate limit issues with the regular 3.5 turbo and definitely with GPT-4. What tenacity does here is a decorator, is an exponential backoff, meaning every time this call fails to get some error, for example, such as rate limit error or something, it starts waiting, starting at minimum of 10 seconds. And if it fails again, it multiplies it by 2 up to 30 seconds. And it does this for 10 times. So it keeps trying for you, right? Now, here's the thing. See, I have 3 different prompts, right? Because if you run this, okay, I've just changed the file name to a test, and I'm going to use only 3 chunks. See, if you run this, you're going to see what's happening. It worked on 3 summaries and saved it right here. And I'm going to skip a little bit forward just to explain a point. And in our next step, we're going to be evaluating. If I run the evaluation step, we're going to see what's going on. See, we're getting scores for each chunk. If we're getting 5, 4, 5. So we're getting pretty high marks because GPT is very good at summarizing. But when we are fine-tuning, we need both good examples and bad examples, right? If you were to fine-tune only with good examples, then you're really fine-tuning the model just to give good marks, right? So this is the part which cost me quite a lot of money to figure out an API cost. So then what I did is, okay, I created 3 different prompts. The first prompt summarizes it in a good fashion using temperature as 1. And then the second prompt actually prompts it to produce more poorer quality responses. And I realized you also have to increase the temperature, see, for average summaries. And then the third prompt really prompts it to produce really bad results. And yet still have to increase the temperature for it to really work. When I did this, and if I were to just run it like this again, and it produces the results, this is the parallel processing, right? It does it simultaneously. Okay, it just did it. Now, if we were to go and evaluate the summaries, I have both the sequential evaluation script and the parallel evaluation script. Let's run that. As you see, we're getting a relevant score of all the scores are very low. We successfully got GPT to produce bad summaries, for example. I created some helper script in test.py file to be able to observe some stuff. For example, if we were to print it, we have 90 rows of data. And as you see, some of them are very good, and some of them are like middling, and then some of them are actually bad. So I tried to create a good distribution of both good examples, middling examples, and bad examples to the best of my abilities, that is. Having said that, let's come back to this. So this requires quite a lot of manual work, but I believe you'll get a hang of it once you examine the code. So we have how many chunks to process, right? So I actually selected 30 good summaries, 30 medium summaries, and 30 bad summaries. Okay, and I actually have here modified the indexes, as in the first 30 will be good, and the next 30, I did it like this, 30 plus, right? And then for this will be the next 30 in our summaries, article chunks.csv. So these will be the middling summaries, and then for the next 30, I did this from 60 to 90, and each time when I was changing it, I used the first prompt, which is for the good summaries, the second prompt, and then the higher temperature for average summaries, and then the third prompt, of course, by commenting out the other ones. Don't forget to do that anyway, and then the same for the bad prompt as well, like this. This is how I was able to produce a decent range of good, from bad to good summary range for our dataset. For the file download at Patreon, I'll leave it at 30. Make sure to switch it to an empty string if you want to handle all the chunks. And then I'll leave this to the first 30. You can modify this any way you like. Here in the GPT summarizer, we are using the instruct with this prompt, summarize the given document under 30 words, keeping all essential information. We insert the document and ask for the summary. With temperature 1, mix tokens 500. There is also a parameter called best of. Okay, if you actually turn this on, it will generate however many you have entered here, alternatives simultaneously, and actually will look at its token probabilities and will return the best one. However many you enter here, you will be generating that many responses, and each of them will consume tokens, but only one response will be returned to you, the best one. Here we have some error catching. Other than that, we just return the summary, and we return a dictionary of both the original text and the summary of it. Then we define max threads 10 because we're going to use thread pool executor, and the rest of the stuff is just running this in parallel. Okay, that's it. When we run this, we get parallelized summaries, and we write them to the appropriate file, which we have named all the way up here. Okay, so I'll just leave it like that, but feel free to change it. As you can see, I have actually used it to create good summaries, average summaries, and bad summaries. Each one of them right here have the summaries from the chunks. If you're enjoying my videos, you can go to my website, www.ecohive.live, and find all my projects. I have over 180 free coding videos. Also, you can find the Patreon code download links. It is a real-time search, for example, for GPT-4, or for example, instruct series and autocoder and whatnot. Now you can look at the descriptions, watch them here. These are all my YouTube videos. The link will be in the description, www.ecohive.live. Okay, so far we looked at the original how to evaluate summaries code. Then we looked at how we can save the Wikipedia articles and split them. Then we looked at how we're going to get the summaries, both sequentially and in parallel using the GPT 3.5 Turbo Instruct. I am really surprised on how well it actually tends to follow instructions. Then next, we're going to take a look at our evaluation code, okay, which uses the exact same prompt, right? But instead of using those hard-coded summaries, we are actually going to open our file, GPT's chunk summary, whatever our file name is. For example, if I wanted to deal with the good files, the good summaries, then I would use that file name. For average, I would use this, right? Okay, I'll just leave it like this for now. You feel free to change this. You do have to change this for whichever file you want to work with. Then we turn it into a data frame. Again, we ask for how many chunks to process. You can again enter here like 10 or leave it blank string for all of them. Same process applies. And then we create an empty list and we loop over all the data frame. And then for whatever we have defined right here, we loop over evaluation metrics like this. We get the criteria and the steps and go over each and every one of them one by one, along with our chunk and the summary. And we call the get eval score one by one. And then this is the sequential, right? At the end of the day, we create a data frame with the evaluation results and we write it to evaluate the chunk summaries, whatever you want to name this file as. I also have the parallelized version of this. It's exactly the same thing, except right here, we do the same thing as opening the file. Okay, and then we define an evaluate row function, which actually does this exact same thing we looked at by calling get eval score. But we call that function with thread pool executor with 4 max workers because we are using GPT-4, as you see. So that's why And we are building the prompt right here because evaluation prompt template all the way up here has some variables needed to be inserted in it, and we define it right here. And then we make a call with it to GPT-4. GPU quickly hit the rate limit of GPT-4. That's why using tenacity is absolutely necessary. And other than that, I found anything more than max 4 workers, you're just going to keep hitting it all the time. Anyway, so this is what we do. And then we extend the results and then create a new data frame with evaluation results, and we save it to evaluated chunk summaries. In this case, since we had the good summaries, average summaries, and bad summaries, we have written it to good, bad, and average evaluated CSV files. Then we have another file. This is step 7 of actually combining these. We give the paths to good, average, and then the output combined evaluated chunk summaries.csv. And then we use pandas to concatenate all of them. And then we create the data frame, and then we just save it, right, to CSV. And that would be this one right here. So this makes a total of 90 rows of data, which we can use now to fine-tune. OpenAI suggests starting with 50. And then if you see good results, then the more the merrier, right? The more data you have in your fine-tuning data set, the better. But since I was going to split it into a 10% validation set, I just used 90. Anyway, feel free to use a little bit more, a little bit less. Like I said, the more the better, but probably a good idea to use 50 to 100 to see how it works. And then step 8, we're going to programmatically create the fine-tuning data set. The fine-tuning data set has to be in JSON-L format, file format, and the structure has to be this. You know how we make a call to GPT 3.5 Turbo or GPT-4, right? So your fine-tuning data has to be in the exact same format. So we create a messages list. We give it the system messages going to be the same for all of our data set. And then we have a user, which I've decided to include. It says document, and that makes 2 new lines. And then the document goes in here. And then the summary goes in here after 2 new lines, summary, and then 2 new lines. And then whatever the summary is goes in here. And then I input the assistant role as the relevance, coherence, consistency, and fluency ratings, which we got by using the evaluation metrics in this complex prompt. And we got these, right? We got these scores using this complex system message and using GPT-4. Okay, anyway, so we have the CSV to JSON-L function, which takes in a CSV file path, JSON-L file path, and a system message, because system message is going to be the same for all of them, right? We just pretty much open whatever our file was, right? In our case, combine evaluated chunk summaries.csv, which includes all our evaluated summaries of each chunk. Its column names are chunk, summary, relevance, coherence, consistency, and fluency. If you scroll down, you can see those right here, as you see. So we read our evaluated summaries, and then row by row, and then we insert them dynamically as a user message, as an assistant message. And then we create the data. System message is going to be the system message. So this is our format, right? Fine-tuning format, just like this. And then we write JSON-L file that. But we're going to call this function for it to work. And before that, we define a system message. This is what I defined. I actually made a mistake here. Here we go. But we could have just said this, for example, just like that. Okay, and this should work just as well. In any case, I just did it like that. You can feel free to experiment with it any way you like. Then to this function, we give it the original file name. We define a JSON-L name, and then we give it the system message. When we run this, we get this JSON-L dataset. Okay, now we are into the fun part. Now we can start our fine-tuning job. So we set our API key, right? Then we open the dataset.jsonl. We read that, we shuffle it, of course, and then we get its length of it, and then we're going to split it into training and test dataset as validation, actually. 90%, 10%. We do that right here. And then we save them. And then we save them to files, summary of training, summary of test. Actually, this is supposed to be validation, but that doesn't matter, same difference. So this file has a lot of things you can use related to fine-tuning and dataset management, but just feel free to comment them in and out, right? Whichever part you need, comment them in, and then run that part of the file, and then comment it out to run the rest of it. I have done this already, as you can see. This is the training set. If we go down all the way, we have 81 training samples, and we have a total of 9 validation samples written in the file. After you've completed this process, you can actually comment this out. And then the next step is actually to upload the file to OpenAI servers, okay? So we're going to upload 2 files. We're going to upload the training file and then the test file, well, validation file. Now, as you see, I'm printing them, okay? So this is an important part of it, okay? Let's just do one of it and see what happens when we run this. Make sure everything else is commented out. Save it and run it. And once you run this, you will upload your file to OpenAI, and if you print it, you'll get an object like this. The reason why this is important is because you're going to need this ID. So this is the ID for our training file, okay? Maybe put it right here or something like that. Give it a name, training file, something like that, because you're going to need this, right? When you're calling your fine-tuning. Just make sure you keep it. Anyway, you just need this, okay? And the same goes for your test validation file. Anyway, just keep that in mind. I'll actually leave them just so you know. Okay, yeah. And then you can actually use this to print all the files that you have in the server. Okay, I believe the newest ones are at the top. Okay, so these are all your files that you have uploaded over the course of time. Now our next step is to create a fine-tuning job. Okay, this is how we do it. We again want to print this. You could have also assigned this to a variable and then print it. I just decided to print it just like this. It's going to print in the terminal, and I'm going to actually save it. We say OpenAI.finetuning job create. We give it the training files ID and validation files ID. You don't absolutely need validation file, by the way. It's recommended, but feel free to not have it if you don't want to. And we can only currently train GPT 3.5 Turbo. I'm going to look into if you can fine-tune the instruct series, the latest instruct GPT 3.5 instruct. That would be great. I'll make a video about it. And then you give it a suffix, okay? So you give it a suffix so that you can know, you can see that suffix is inserted into your fine-tuned model name. And once this fine-tune is created, you can actually call it like you're calling with the regular GPT or API call. You just need the model's name, and the summary evaluator suffix is added in there so you can actually know what you're dealing with. Another really cool thing is that if you go to your platform, the playground, there's actually a new fine-tuning tab, and you can see your recent fine-tunes. As you see, I created this summary evaluator, and I also did this test too from a previous video, which was this video's GPT fine-tuning masterclass. Anyway, and I accidentally started 2 of them, and then I actually canceled one of them, and all the code that is necessary to do all this is here. You can create the fine-tuning job. Actually, let's just go ahead and create it. Since we have these files uploaded, I had kept track of them. We can actually create a new fine-tuning job. Let's see, it's going to print. Oh, here we go. Here we get our ID. So we need this ID, okay? So make sure to save this somewhere. I'll just put it right here, for example. We're going to refer to this fine-tuning from our code using this. I did this previously like this, as you can see. This was my previous fine-tuning job. But anyway, now that we started this fine-tuning job, as you see, this fine-tune has started, okay? You can actually keep track of its status, right, straight from the playground, but we can also keep track of it from right here. First of all, now that we have created our fine-tuning, sorry, I keep going to the wrong VS Code window. Anyway, now that we've created our fine-tuning, we no longer need this, okay? And we have saved our file name for reference. Actually, let's move it over here, so it's not cluttered. This is for example purposes. One thing we can do is we can list the 10 fine-tuning jobs which we had created in the past. I created quite a many previously. They don't all show up here because some of them are from a few years back. This interface is actually very new, and it doesn't include your old fine-tunes. Anyway, as you see, these are all the old fine-tunes succeeded. When you print something from OpenAI servers, the last one is the oldest one. Okay, so you have to scroll up. And as you see, this is the one we have started. It says validating files. Oh, sorry, it actually says running right here. Status is running. So you can use this to list your fine-tuning jobs. And then with this one, you can retrieve the state of a fine-tuned job. Okay, remember, if you were to retrieve this an old fine-tune, if you actually run this, it's going to retrieve the status of an old fine-tune, which says succeeded. Okay, but we want to take a look at the latest one, which we just started. So let's run this. Okay, see, this one says running. Okay, Yep. And it's giving you which files it's using. Now you can, with this one, you can cancel a fine-tuning job. This is what I use to cancel this one right here. With this next one, you can actually list the events from this fine-tuning job. Again, you need the ID of your current, whichever fine-tuning job you're looking at. Let's put it here. We're going to ask for, let's say, 1. If you say 1, we're going to get the latest event. And the latest event is that we've just started training, and this is our training loss, and this is our validation loss. Okay, so we get some information, as you see right here. We can change this to, let's say, 3, and let's see what that looks like. Okay, so this is again from bottom to top. It says fine-tuning job started. Next update is at step 1. We've looked at it, and the next update is at step 11. As you see, our training and validation loss is going down. This is exactly what we would like to see. So if you actually look at my other one that I was just showing you, which I created, as you see, both the training and validation loss was going down. This is a good sign that actually the model is learning. This means that according to OpenAI, it says that to start with a low number of data points, such as 50 or 100, and make sure that you're getting progress. In this case, we can say that we have gotten progress. Then they say that then expand on the data set, maybe use 500, 1,000, 5,000, more the merrier, like we said. And if you come here and click on our latest fine-tune, we also get to see its results right here. Fine-tuning job started, files are validated. Yeah, and it keeps updating. This is really nice. So you can do that to retrieve the files. You can also delete a fine-tuning job, but the fine-tuning job has to be first created. While it is fine-tuning, you can cancel it. If it's canceled, you cannot delete it. But if you have an actual fine-tuned model, then you can actually delete it by giving it right here. Okay, and the ID would be, in this case, I believe, if I'm not mistaken, the name, the entire name of your model, like this. Okay, you would paste this into this code and then delete it. But I'm sure OpenAI, from the looks of it, will be maybe introducing it here as well. I don't think you can delete it here, metrics. So you can see our metrics as well. So this is pretty awesome. And after this, then you can actually play around with it. Here I'm going to grab a part of the pyramids Wikipedia article. I'm going to come and enter as a user message document, and I'm going to make 2 new lines, right? And then paste it right here. And after that, I'm going to say summary, because this is how we build the data set. So you have to be true to it. So we're going to enter a summary here. Like I said, these are about triangles. Let's just say that, because after all, pyramids are a bit triangular shaped. So if you come here, we do have to use the same system message. So let's just grab it from here. Okay. You do have to do that. Okay. So think about all this ahead of fine tuning. So now we can just run this by selecting our fine tune. Let's say if we use GPT-4, let's see what GPT-4 says. See, it's doing a bunch of stuff, not what we want, obviously. Cancel, delete. But if we go to our fine-tuning model and then run it, we immediately get the result that we fine-tuned it for, in the exact same way that we fine-tuned it. If we say this is about monumental structures in Egypt and delete this and run it again, so then it has very high scores. Fluency is measured out of 3. Okay, so this is how it works. Let's take a look at the fine-tuning job and see what's happening. It's going swimmingly. We're almost done. We can also look at an update right here, right? Again, I went to the wrong window. Right, we need to call the list events to see what's happening with our model. And here are the events, 211, 221. It's almost about done, okay, shortly. So this was pretty slow previously when it first launched, but it's going pretty quickly these days. And the loss have been coming up. It seems it just came up in the last iteration. I believe if we call it again, it should almost be done. Almost. Anyway, it's getting it. Once this is done, it's going to say succeeded. And then you're going not only going to be able to see it here, but you're also going to be able to see it under your fine tunes. And it actually was just created, as you see. It was just done. If you go to our fine tune, it was created. It's H1RA. So it's the exact same one as the previous one. Just to see, let's delete this one. Okay. Let's get its name because this is a duplicate, right? We already had this. So you can see how to delete. Fine tunes as well. Let's activate it, I believe. I'm not sure if we need to use... I'm just going to see if this works real quick. Yeah, okay. Yeah, I believe we just deleted it. Let's go back and see in our fine tune. Oh yeah, if we go to our fine tune, see it's no longer showing up as a model we can use. We have successfully deleted it. I hope you enjoyed this. Like I said, you can find many other exciting projects easily at my EchoHive AI Academy. Link is www.echohive.live. Link will be in the description. And also check out my Patreon. This is all I do all day, every day. And when people like to support me, I really appreciate it. But also it's a great convenience to be able to download the code and experiment with it. Take a look at AutoAGI. I'm particularly proud about that one. Anyway, thank you for watching. And I hope you found this helpful. Let me know what you think in the comments. If you'd like to talk about large language models, join our Discord. Link will be in the description. And see you in the next video.